tutorial discusses carboxylic acids. In a carboxylic acid, we have a carbonyl group, which is the carbon-oxygen double bond. We also have a hydroxyl group, an OH group. It's considered an acid because this hydrogen here will be given away, and by definition, an acid is something that gives up a hydrogen. Just some names of some acids. This, notice 2 carbons. Eth is 2 carbons, so it's ethanoic acid. This one has 3 carbons, so it's propanoic acid. And this one has a benzene group, so it's benzoic acid. To name these, you may have noticed that those seemed rather familiar. Essentially, you're going to take the straight chain name, like methane or ethane, take off that E, and add oic with the word acid. Take off the E, add oic with the word acid. So if we look at these, we always count with the 1 being with the double bonded oxygen. So there's 4 carbons in a straight chain here, so we have butanoic acid. On that 3rd carbon, because remember we start counting at that double bonded oxygen, is a methyl group. This one is a benzene ring. That first carbon is where you'll find the carboxylic acid. So that's the benzoic acid portion. So carbon 2 and 3 both have chlorine, so it's 2,3-dichlorobenzoic acid. Something else I want you to realize as we're looking at these is that when we're looking at carboxylic acid, just like aldehydes, it's considered a terminal functional group. It will always be at the end. Or actually, because it's always a 1, it will always be at the beginning. It will never be in the middle somewhere. Alright, so some common names. Here, we just simply memorize these. There's no way around that. So formic acid is 1 carbon as methanoic acid. Acetic acid, which is actually vinegar, is ethanoic acid. Propionic acid is propanoic acid, and butyric acid is butanoic acid. A couple common ones that you might be familiar with you don't even realize is formic acid, which is it's in a red ant sting and it hurts really bad. And vinegar is ethanoic acid or acetic acid. So let's practice naming some. Remember, with that double bonded oxygen, that will always be your first carbon. So 1, 2, 3, 4, 5. So 5 carbons. That gives me pentanoic. It was pentane. But because of this OOH, it's going to be OIC. On that second carbon is a methyl group. Another thing I want to point out right now is the fact that sometimes when you have it written out, you'll see COOH. That and that is interchangeable. So if you see COOH there, that means that you have a carboxylic acid. Let's try another one. Here's that carboxylic acid. That's 1, 2, 3, propanoic, propane, without the E, and you put OIC, acid, propanoic acid. On that second carbon is a methyl group, 2-methyl propanoic acid. Here's my benzene ring, and on that is a carboxylic acid. That becomes benzoic acid. We have to figure out where that bromine is. The carboxylic acid is always on the first one, so 1, 2, 3. 3-bromo benzoic acid. Finally, let's take one with a name and let's try to write it. Remember, when you were given it this format, just take it one step at a time. I start from the end and work my way forward. So hexanoic, that means I have 6 carbons. One, two, three, four, five, 6. On that 6th one, I have a carboxylic acid. And then on the 4th carbon, I have a chloro. 1, 2, 3, 4. Now, it's actually asking for a skeletal structure, which means I need to convert this into the line format. 1, 2, 3, 4, 5, 6. On that 6th one, I have the carboxylic acid. 1, 2, 3, 4 is the chlorine. And there you go. That is your introduction to carboxylic acids.